Hello, everyone. Thanks. My name is David Yiptong. I'm the manager of partnerships and ecosystem at Quantum City. If you haven't heard of Quantum City, we are affiliated with the University of Calgary, and we're a group whose focus is really on industry adoption. We like to say that Quantum City is where quantum technologies become quantum solutions. And one of the ways that we do that is with industry challenges. I know there was some discussion earlier on today about creating quantum literacy. And our team always talks about it in terms of receptor capacity. We've run some challenges with electrical utilities in Alberta. We've run a challenge with a major Canadian oil sands producer. And we actually have an open challenge right now with the city of Calgary around quantum safe communications. So the idea is to give these industries and these corporations an opportunity and to expose their teams to the technology, expose their teams to the process, and hopefully provide feedback to the solution developers. So I'm really thankful for Michael for inviting me to host this panel. When I saw the names, when he sent me the email with the names, I couldn't believe it, but this is a great panel to have. And I think all of the discussions that were happening up to now, in a way, we're talking about this group of four right here. So this is an opportunity, I think, for them to share with you their perspectives on the ground, their real life perspective, their lived experience. So I'll ask them one by one to sort of introduce themselves and their companies, and then we'll go into some questions. So to my right here, I have Alex Maierean from Phantom Photonics. We have, oh, you guys didn't sit in order. We have Kyung Choi from Q Block, hailing also from Alberta. And we have David Roy-Guay from SBQuantum. And then we have Rafal Janik from Xanadu. So these are all Canadian companies. These are all Canadian quantum companies. So I guess I'll start, David, I'll start with you. I'll ask you to introduce SBQuantum to the crowd and tell us what you do.
All right, great. Well, thanks for having me here. So yeah, SBQuantum, our mission is really to unlock the full potential of magnetics. From our perspective, it's a ubiquitous resource that's massively underutilized. So we're a 21 people company based in Sherbrooke, where a few of our staff are in Montreal and even in Fredericton. So yeah, we're distributed across the eastern part of Canada. And really, we're at the pre-commercial stage. So I brought one of our sensors here. So it's real. It's flown on a drone. It's been on a weather balloon up in the air and crashed in the lake, and it survived. It was qualified for space operation. So at this point, it's ready for field deployment. And we've been engaging with CAF and DRDC along the way. So if I backtrack a bit, at the inception of SBQuantum, really my objective was to engineer the quantum technology, even though it wasn't ready or fully mapped out how to miniaturize and have the most performant version of this technology. So we just said, hey, let's take whatever is on the shelves and let's start building the technology to go from an optical table to something that is portable that we can take to end users and figure out what value we can bring to some novel use cases. So we tried initially going for big contracts, the security program from Canada. So $1 million contracts didn't work out. We were two people with a sign saying, hey, we're great. So it didn't work out. So we tried that a few times, and at some point the IDEAS program got launched, and we applied to the first inaugural call on a challenge that was labeled as detection and classification of objects, and really very general problem statement. And we said, hey, we're just going to do this with magnetics and maybe with fusion of sensors. So that's how it started. A small contract, $200K, open bid, like it could be any solution, not restricted to our technology. So we got 200K, started prototyping, building on what we had done at SITREP-Q in Sherbrooke. And really, SBQuantum was very visionary in terms of giving the opportunity to students to have their own funding, not only professors. So that was the initial push for me to join forces with electrical engineers and start building the tech. So went from this 200K contract to a subsequent phase, 800K. Then the testing stream of ideas. Yes, it took a long while to get going to the testing stream. We were the initial cohort. And now we're into procurement through the testing, the test drive phase. So actually, we're going to deliver 3 backpack units to CanSofCom, in which there's 4 of our sensors to see beyond the wall. So what we've developed is not only the hardware, but all the algorithmic stack that is kind of customized to the end user. So CanSofCom, because they want to know, they want to anticipate the threat before they enter a room. So in the backpack, we have 4 of these sensors, customized algorithms with a very simple interpretation of what's going on beyond the wall that is being fed to the end user. So we're right there, right at the point of deploying the technology, getting the feedback from the end users, and looking at the additional procurement phases through ISC. Our experience is pretty smooth so far, I would say. Definitely not in the year region. So we're really excited, but we're beginning to get the feel about the secrecy, reliability status, and all the security clearances. So kind of learning along the way. One of our big successes, so that's on the Canadian side, is also on the American side. So after a year of developing this technology for CanSofCom, there was a open innovation challenge launched by the National Geointelligence Agency in the US to have their sovereign capabilities to build the world magnetic model, which is in every electronic compass, including your cell phone. When you're taking out your cell phone, looking at the blue arrow to say, hey, I gotta go left or right, you're using that map. So it's really critical infrastructure provided for free for now. And the US wanted a backup method to eliminate the dependency on the ESA mission that is at end of lifetime. So went through successive phases, partnered with a company called Spire Global that are developing CubeSats. So we bring the payload, all the magnetics intelligence in terms of providing high accuracy of data, which is the key advantage of our technology. So now we're at one of the last phases. We're launching in space at the end of March. So stay tuned for the announcement. And we're going to begin collecting this data, which could feed into magnetic maps for navigation when GPS is not available, which is very relevant in the current context. So yeah, that's a bit of the story of SBQuantum.
Parfait, merci. Kyung, let's go with you. You tell us a little bit about Q-Block.
Can you guys hear me? Yeah. So my name is Kyung Choi. I'm the co-founder and CEO of Q-Block Computing. Q-Block Computing is a quantum hardware company focused on delivering fault-tolerant quantum devices for advanced computation, communication, and sensing. We work in 2 market segments. So one is what we would normally call enabling quantum technology. So this is a market where we sell ultra-stable laser system, quantum limited photodetector, high-speed optical modulator, ultra-high finesse reference cavity. I'm sure these are very foreign names to you. It's a laboratory equipment for researchers to carry out their research in quantum science and technology. But what we also do is we actually take these 4 products, integrate them into a little box, put a little custom silicon on it called Q-Block module. And these are essentially an integrated quantum photonic platform where the phase and the timing are fully synchronous to each other to scale up to larger systems. And with that, we directly address the end user market in defense and security. So there's quite a bit of limitation of what we can talk about in terms of what is being deployed in the Canadian Armed Forces or at the DND. But at least publicly, we have 3 products. So one is Q, which is a quantum timing solution, and I don't know, Lisa already took the line from me about the kind of the deployments that one can imagine for Arctic over the horizon radar systems. So this is basically a sovereign timing solution where the clock is ticking instead of our frequency at the optical frequency, and we have a way to actually convert that coherently in the optical domain to the RF to actually gain that same stability and achieve about 10,000 times better timing stability compared to GPS, direct GPS sustained synchronization. So what that means in practice is you synchronize 2 clocks together in a maybe annual maintenance. You keep it on for a couple of years, it still doesn't deviate by 1 nanosecond. And one direct GPS synchronization is about like tens of nanoseconds because on the Earth ionosphere, there's a lot of kind of weather that happens, and you actually cannot get much better than that, even in a sustained synchronization manner. The use case for Q, our quantum clock solution, on the one hand, is obviously GPS independent navigation, PNT application, but increasingly it becomes much more important for precision, long-range, high-performance radar systems. So the example that Lisa brought up around the Arctic over-the-horizon radar system, look at OTHR. It's been around for, I don't know, since the 60s. What has been a game changer is the integration of quantum clocks to these large-scale infrastructure. And that's what the Australian Jordan Arctic Over the Horizon Network is known for. So if you kind of like think about what these guys are doing, you have a multiple radar elements that is distributed over hundreds of kilometers, and then you send a low frequency wave to the ionosphere, reflects back, and you're looking on the ground. So when you're looking on the ground, there's a huge amount of signal just from the ground clutter, and then you're trying to detect an object that is moving at a very slow speed. And so this translates into detecting a signal in the presence of significant amount of noise, which is very different from looking up into the sky. And that's also why better oscillator is actually incredibly important, because that's what distinguishes an object that is moving in the presence of very large amount of noise. Yeah, so this is exactly a problem of better clocks, and that's also the reason why the first functional massively deployed system had to integrate these quantum clocks. I'll get back to the quantum clock piece again. So we also have Lucia-Q, which is on the communication end. So what this is a first generation quantum repeater node. So this is a system where you can do scalable long distance quantum communication. There are certain benchmarks that we need to beat. It's a little bit like the kind of the quantum computation advantage moment called plot bound, but for communication, we want to be able to beat that plot bound to really demonstrate for the first time that these quantum repeaters are actually functioning. But the piece where it becomes very much relevant for defense and where defense is interested is the ability to transfer time standards. And again, going back to the quantum timing, if you have multiple radar systems geographically separated, you want to actually synchronize those radar systems really well. It does require a lot of the technology that is shared with this Lucia-Q quantum repeater node. Lastly, we have Polaris-Q, which we've made public very recently, which is a tweezer array quantum computer, a tweezer array neutral atom quantum computer on the edge. The use case for this is not so much on quantum computing. I think we probably all agree that we don't yet have a fully fault-tolerant quantum computer that could be massively deployed and actually generate real value today. However, it turns out that there is another paradigm of something called quantum computational sensing. So this is an area where you use a quantum computer to generate metrologically useful entangled states on the qubits. And those qubits also happen to be very good RF sensors. So this is actually a platform, a test bed for defense researchers to generate different types of non-classical states, entangled states, and actually test out different quantum protocols. Yeah, so that's called a Polaris-Q. I guess one thing I just want to like maybe kind of throw out as a discussion point is, as Lisa mentioned, like Canada has been at the forefront of quantum technology for the past 20, 25 years. It started from D-Wave or the kind of the initial investment that went into the Quantum Valley ecosystem in Waterloo. I should also mention IQC actually is sort of our father. Like, Q-block computing was born out of this IQC Quantum Valley ecosystem. And that remains to be, the case. Like we better maintain that technological leadership, and that's really signified by like these Quantum Champions program, which is incredibly important. I think there's another story that hasn't been told very effectively, at least in the public sphere, and this is around like really trying to generate productivity today. And going back to the over-the-horizon radar system to maybe add a little bit of color to what Lisa described. So you think about what is the kind of economic multiple of this. The quantum clock might be about $10 million, but it's not a nice-to-have system. It's actually a foundational quantum technology where without it, the $60 billion defense platform simply does not work. So then it's a little bit of question about, I think one of the criticism that, quantum sensing technology gets is it's a very important component, but not a full system that the defense can procure. And that's true, it's a component. But then when you think about like a personal computer, like, what Dell creates, is Intel more important or Dell more important? And that's a little bit the analogy that I'm trying to make here, where foundational quantum technology is a little bit like the Intel Inside for these, large defense platform. It's not always the case, but there are some cases like this, especially around quantum timing, and there are other examples. And I would hope that when a lot of these discussions on the defense industrial strategy and how do we actually grow SMEs to be a neoprime and these kind of system integrator, we really think from this angle of fostering foundational quantum technology and really valuing it, at the value that this technology delivers to these large defense platform. So yeah, with that, I'll conclude.
Thank you. So as you can see with what he just said, like they have definitely moved past the sort of science project phase, which is great to hear. Alex, do you want to go next?
Yeah, thank you so much. Hi, everyone. I'm Alex Maierean. I'm co-founder and CEO at Phantom Photonics, and we're a company that develops quantum LiDAR, rather technologies based on quantum LiDAR. Our sensors can do imaging, 3D imaging. They can do communications, optical communications, and spectroscopy. Spectroscopy being the ability to tell the chemical composition of what's in front of you. Our tech can see farther than existing LiDAR by 10 to 100 times. It's stealth and it's unblindable. In this sense, it has a lot of very interesting properties for defense applications. And today we are a team of about 10, depending on how contract negotiations go, maybe 13 at the end of the day. We are housed at the Velocity Incubator in Waterloo. We are a spin-out from the University of Waterloo, specifically the Institute for Quantum Computing, where I was doing my graduate degree. And let's see, we had the fortune of being part of the Innovative Solutions Canada program, which gave us a big kickstart to developing our tech. We've also had the fortune of going through the NATO Diana program, which opened up our beachhead market as a startup, which was the maritime space, very interestingly. Turns out there are not a lot of choices for sensors to use underwater. And sonar is kind of the primary one, but it's really loud. And from a defense perspective, that's a bad thing. LiDAR, which uses light, is quiet. And so any advantage in the range that you can see and in the stealth makes a difference. So that's kind of the big first application we're going after. That said, and as Lisa alluded to, we are also seeing a lot of immediate interest in the nuclear sector. And that goes for problems like finding jellyfish that might clog up the water intakes for nuclear power plants, which apparently is a massive, massive problem that shuts down power plants for days, to finer grained problems like finding cracks in the welds of the pools that hold the nuclear reactors. Apparently, they're giant pieces of metal that are welded together and they crack and they leak radioactive water. It's a mess. So they need help finding the cracks. So from observing the ocean and I guess these sort of macro sensing solutions that they need to very fine-grained solutions, there seem to be a lot of applications. So what we've developed is a rather versatile technology, and we are prioritizing what applications we go after as in order of market size and accessibility. Some markets are bigger, but they're harder to attain. For example, outer space. Our tech does work in outer space as well, or it should. Not that we've sent anything up there yet. But it takes a lot of time and a lot of capital to access that market. And so we're just trying to diversify and also develop a tech that's useful.
Thank you. And definitely not least, but last is
definitely
Rafal.
least. I was invited because Michael doesn't actually know me, so
Oh, okay.
he doesn't know the inflammatory statements I'm about.
He doesn't
to
know
make.
what's about to happen.
Correct. I'm Rafal Janik. I work at Xanadu. We're a photonic quantum computing company. We have a pretty straightforward mission. It's to build quantum computers that are useful and available to people everywhere. That useful part is a pretty big challenge. And normally I have like a group of IBM people I can start to aggravate at this point in time, pointing out that nobody's yet built that useful quantum computer, no matter what is kind of set out in the public markets. We've been working on this for now close to a decade. We have 270 people based out of Toronto. I'm going to say over $350 million raised between private venture capital and government support on that mission. Huge amounts of IP generated, including a very notable quantum computer we put online in 2019, which was our first photonic quantum computer available broadly and anywhere in the world. And then in 2022, we followed it up with Borealis, which the Canadian government stole the name from, which was at the time the world's most powerful quantum computer. We took the title away from a Chinese effort out of the University of Science and Technology in China. And this was a quantum computer that was able to perform a very specific mathematical task in 2 minutes that at the time would have taken the world's largest supercomputer 7 million years to do. And when we talk about quantum computing, what I really want to highlight is we're not discussing 10% savings over traditional supercomputers. We're talking about fundamentally being able to do things that are impossible to do computationally with classical computers. There's a really big effort on finding those applications, and that's another area we focus in pretty aggressively as well. But what they require is fault tolerance, so the ability to be able to correct errors as you go along. And you might have heard things like logical qubits mentioned in terms of qubit counts or versus physical qubits. And a logical qubit is just one that has been corrected to some extent. And right now, based on the work that we've done, others like the Google Quantum AI Lab have done the best applications that we have fit into about 500 logical qubits that can perform 1 billion or more operations. And if you want to think of how many physical qubits that is, given existing systems, this would be million qubit quantum computers, so much, much bigger. And the general consensus is today that that's not going to happen on a single chip. You're going to need to network multiple chips together. And in fact, just last year, right around this time, we published a paper in Nature that demonstrated for the first time that true modular networkable architecture in a quantum computer put online. And that's our Aurora platform. It's been running now for a year. It's one of the most complex photonic devices ever built. And it's in fact also the most complex quantum network ever stood up. We have tens of chips generating billions of modes that are all entangled for hours on end. In fact, we've run it for days without needing any sort of recalibration. It's still not enough. If we had a little knob that we can turn on that quantum computer to reduce the error rate, it would be enough, and we could just build that data center now with 500 logical qubits and start generating that hugely outsized economic value. But unfortunately, that requires more manufacturing cycles with our partners, mainly foundries that design and build the chips in your phones and computers. We're working directly with them to continue developing the chip platforms to reduce our type of noise, which is photon loss. How much light gets lost through the chip as our pulses of light actually carry the quantum information. And this is something we hope to bring online quite soon, but it just requires more time, more capital. And that to that end, you might have also heard that we're in the process of going public and attempting to raise another $500 million USD in order to put towards this goal. That's all the hardware side. Uniquely, we also have a major software play in a platform called Penny Lane. In order to make quantum computers useful, not only do you have to build them, but you also have to have a way to program them. You need to have people trained in understanding how to take real problems and map them onto a quantum computer. And we've been very heavily engaged in that effort. Last year, if you asked me, I would have told you there's only two ways to program a quantum computer realistically. It's either Penny Lane from us, which shares the market equally with IBM's Qiskit. Very honestly, right now, NVIDIA has thrown a huge amount of effort into becoming a player in the quantum software space as well. And they're quickly coming up with very large investments in, I would say, third place as another option. To that end, we're engaged with a large number of commercial players, helping them develop real applications for quantum computers. I'm going to say these are not toy problems that will run on today's quantum. But these are really targeting generating IP for the quantum computers that'll be here in 3 or 5 years. And these are companies like Rolls-Royce, mainly looking at fluid dynamic simulations, Mitsubishi Chemical looking at next generation semiconductor materials, defense contractors that are looking at various QML type of approaches for their fundamental problems, and many folks in between. And we also engage with now close to 175 universities worldwide. And this is mainly on ensuring that Penny Lane gets into the hands of people early enough to make sure that we're developing that workforce of the future. So even here at Queen's University, there's a number of undergraduate and graduate courses that are actually taught that include Penny Lane as the foundational piece for teaching quantum information theory and actually getting people hands-on, whether it be with just a quantum simulator or with a real quantum computer. Uniquely, Penny Lane isn't restricted just to our hardware. It works on any publicly available hardware, and we partner with companies like IBM and IonQ, IQM, in order to actually make sure that their hardware is fully supported within that software stack. One thing I did want to highlight is that, being a quantum computing company, we're in a uniquely different position than a lot of the companies you heard of here, where our time to market is incredibly long. The investment we need is very high, but the underlying technology is the same. You heard it already mentioned that you could use a quantum computer for sensing. Realistically, it's all the same technology, all the same principles. And one of the challenges that we face is that we're sitting on a mountain of IP in the quantum photonics space that has direct applications of quantum sensing and quantum networking and classical compute. And very often we face this problem of what should we commercialize? And one of the asks to the folks at Defense that are made is help us understand what the parameters of the problems that you're facing on. Because there's a good chance that we have a technology that we can license to somebody, or we can actually develop that product on our own in order to bring a real solution into the hands of folks at CAF in order to actually move their mission forward. But this has been a massive challenge. We're limited in funds, we're limited in people. We have this monstrous goal of building a fault-tolerant quantum computer, and we definitely need help guiding where we can generate that early value before we bring that quantum computer online.
Thanks. Now that you've heard from all four of them, there's a lot to unpack in everything they said. I think, they talked a lot about even just adoption or even the feedback loop that's needed that would be beneficial to advancing technologies and accelerating. One thing that I find really interesting as well, Lisa had a slide that said, Canada has strengths. And I find it very Canadian that we always need to remind ourselves about what our successes and what we've been good at. And I think the four companies you see represented here are just a part of the Canadian quantum ecosystem. So with that, all of you have interacted with government, with policy, and with funding. And some of you have interacted with defense as well. Can each of you tell us what has gone well in your experience so far? I know there's been a lot of doom and gloom in the morning about how nothing's working, but what has gone well? Because you're all still here, you've all still survived. What has gone well with funding? Kyung, you want to start us off?
So like Q-Block computing started off from the University of Waterloo. So just that initial investment that went into IQC, supporting the basic science that led to the inception of Q-Block computing, that was, a foundational contribution. I think also at the same time, the engagement from DRDC and also encouraging us to form a company, that was very helpful. And I think the other part is really the sustained support from the ISET on the Innovative Solutions Canada challenge and testing stream. Challenge stream for the low TRL to push it to higher TRL. Testing stream for actual pilot deployments. Introduction to the CAF members. Making that connection to move to that next stage of, deployments. Engaging directly with CAF. And I think what I also noticed on the defense side is surprisingly, CAF members are very open-minded. That's what I feel, especially when that introduction through DRDC is made properly, and then when they actually do see the value. And I've seen them to be the biggest champion of a lot of our technology. And although I'm supposed to only talk about the kind of good things, the challenge is to translate that, good intention and intent to procure into an actual procurement. And that's the main challenge that we see in terms of, adoption.
Thanks. David, do you have some thoughts on what has worked so far in the support ecosystem for your company?
Yeah, absolutely. So definitely the IDEAS program have been awesome for us. It really brought SBIR-like capabilities. So SBIR in US is kind of a phased approach to stimulate innovation. So it's really great that now we have this option that is really focused on the end user problem. And really allows any type of player to play at early stage to a long-term stage. So yeah, for us that has worked great. Sometimes it was a bit longer, but overall, it's a big part of our success. Also, like there's some hidden all-star players behind us. Like it's not known, but Canada for anti-submarine warfare is quite strong, and in magnetometry as well. So CAE in Montreal has almost a monopoly over the magnetometer that's being used for anti-submarine warfare. So there's lots of expertise laying around, like government labs that you can access. So in Ottawa, the Geomagnetic Lab has welcomed us to qualify our magnetometer, and that capability was key to, after that, go see like the other partners or customers in US and tell them, hey, by the way, we have access to this world-leading facility in which we can actually show that our device works as intended. So, I guess like the ecosystem and all the defense world is very supportive, and now it just needs like that push to get it across to procurement and like to really getting the resources aligned.
Rafal, your company's been around. Well, you're going public, so you've been through quite the journey. What has been some of the positive supports you've received along the way? Things that you'd want to see continue, for a more junior company.
Yeah, I mean, I think things are very honestly improving day by day. Like, it's been interesting now where we are, that we always kind of feel that we've outgrown the supports that we fight for. So as we go along, like every single time I've asked the government for money, I always I wish I'd put another zero on the end of that, because by the time we get it, it's just not enough. But very honestly, I think the biggest thing is that it is a collaborative effort. Like, even though very much we are companies that are competing with each other, there's a realization that we all want to see quantum in Canada succeed. And uniquely, their government partners are very much involved with that. As much as, myself and other Michael might disagree at times about, what the right thing to do is, whether quantum sensing is real or not. The really big
You are outnumbered on this panel.
I am. But we're all marching like together. And I think a big example is what Lisa has been able to do with QIC, where, personally myself, I wasn't necessarily a believer in that underlying model originally, that this would be the way to push success, and definitely proven wrong, and super happy to have been along for the ride. The other big thing I'll highlight is Canada's immigration policy has been critical to the success of quantum. We often talk about workforce development, and very honestly, we don't have a problem with workforce development. We are leaders in training quantum engineers and quantum scientists from all over the world. Unfortunately, they leave Canada and go work other places because we don't have the industry in order to support it. But for all the companies here, and I'm not sure what it looks like for the other ones, but for us, more than half of the people that we have, we brought in on visas. Many of them started training at Waterloo or at Sherbrooke or other places, but very quickly we were able to make them residents and citizens of Canada and bring that highly skilled talent here. And the support of the Canadian government through that has been incredible. When we hit roadblocks, the ministers are there and understand that this is critical. So it's been a great partner to have. The only thing I wish they had was another couple $100 billion in order to fund us all to the levels that we need.
I think you touched upon sort of how multifaceted the supports need to be, right? It's not just a defense question. It's not just an industry. We were joking about whether it's a financial question, right? Things like investor tax credits and things like that. But you had mentioned getting support from people within, was it defense you're talking about earlier on at lunch? People who'd gone above and beyond. You want to talk a bit about that?
There we go. Yeah, we definitely had a lot of support along the way. And I like to think that, and we're probably the youngest company here because we're not even 3 yet. We entered the space at the right time because of this defense ramp up. When you're talking about a quantum technology, and this also harkens back to a point that was made that maybe we shouldn't be necessarily putting it out there that it's quantum, it's just better performing. But when you do mention quantum, people kind of get scared. And in the civilian sector and companies that do innovate and do innovative technologies don't really support smaller companies. So we end up as quantum innovators having to look at defense who is willing to support something that is a little bit more deep tech, a little bit more risky. And as kind of the geopolitical situation changed, what was already quite a solid base for very early startups here in Canada that do this deep tech became also a really big support for scale-ups, which we are kind of starting to transition into. And the government employees they've been working overtime. Like across the board, everyone that I talk to is putting in so much effort that, I mean, it's really thanks to them that at this point in our development, we're able to move forward in a timely manner. It's really that simple. Like civilian industries are not there enough for us to be able to sell into or to collaborate with to develop. It's the government that is crucial at this point in time, and they're delivering.
So those are some of the ways that things have gone well, and you know, for all, like I said, your companies all exist. You're still in operation, so there have been positive supports. This is a policy discussion, and I think, like you saw today, they're looking for input. So, what are the need for improvement areas or the challenging areas that you've experienced? Some of you have experienced defense ones. All of you have experienced some sort of funding application. So, yeah, are there specific areas in your memory that are burned into your memory that could really be improved or could have really allowed you to grow faster?
Maybe I can start. So there's 2 points. First one of them is procurement of innovation. So quantum technologies is in early days, and often what you're trying to sell is the first time it's being sold. So then comes the question, how do you price it? How do you justify the pricing? And it's a bit weird question to answer because they're the first clients. So in our case, we were very lucky. We sold our first device to the French, so we had a benchmark. But very easily, it could have gone down a very long, winding road of justifying the R&D that went into it, the price of resistors that go in the device, and all that jazz. So yeah, there needs to be this understanding that this is breakthrough tech, and to figure out a way to accommodate the innovators. The second point is like just access to end user like problems. Like for a company, like it's all about like generating value or solving problems for a customer. So if we cannot really have any information about the end use cases early on, then we're kind of developing the technology based on our own assumptions. And that's maybe not the most effective way to develop a technology. I'm not sure what we can do about it, but it's really an issue for startups and for the field of quantum techs. Yeah, those would be my 2 main points of improvement.
Thanks. Any thoughts?
Yeah, I mean, I think the easy one is just to say more funding, but I think there's real limits to that. So my second one would be I'd love to get Joseph and Michael actually to come work at Xanadu for like a year and try to work with the Canadian government to get an understanding of the challenges.
We were joking, kind of like Undercover Boss.
Yeah, no,
Yeah.
but the more I think about it, I'm like, this is actually not a stupid idea. The challenges, around procurement are different than the challenges around funding. And I think the first thing I would suggest is that we've often struggled with getting an understanding of just what is the strategic importance for the government. Is it really that they want to procure a technology that meets a need? Do they want to fund an industry, a supply chain, and grow that piece? And it's difficult to have that transparent discussion. And again, maybe it's alluded to the worry about procurement rules and whether or not we're going to get into trouble. But this is very differentiated with the provincial governments that we've worked with, where the provincial governments will come to the table and say, we need jobs, or we need a technology, or we need a factory. And it's super easy to then say, like, absolutely, we can do that, or there's no way that this is something that's currently in our field. The other big challenge, very honestly, is that we're shoehorning the funding through programs that were never meant to fund deep tech. And you get really, really bizarre problems. And there's one that's come up in discussion here repeatedly, which is the protection of IP. And personally, I don't know very honestly what type of IP we're talking about. Are we talking about patenting? Are we talking about trade secrets? Are we talking about know-how? Because all of those are protected in different ways. And none of them I can protect without a domestic supply chain, because we're going to trade all that IP for access to manufacturing in a second. So it becomes this bizarre conversation. And what it ends up being is clauses that in no way protect our IP in government contracts, but are a poison pill for foreign direct investment. And we face this. We've received government funding. It exists. And I've spent time talking to investors, explaining to them like, hey, everything that's in this contract is in the Invest Canada Act anyways. So really, there's no difference between these two pieces. But you'd be surprised at how impactful that could be, especially for a young, high-risk company that is potentially looking at investors that aren't very sophisticated and maybe just don't want to deal with them having a complex government contract on the books. So the next thing I would highlight is, if we're serious about innovating in Canada and capturing this or AI or any future technology, we need to move to funding vehicles and bureaucratic systems that can realistically support that and respond in a timely manner as technology shifts, because it changes quickly. So it's not just that procurement needs to be fixed, but I would say the strategic funding side also needs to be fixed. We're not building a mine, we're not building a factory most of the time. Most of the time, we're trying to do some complex R&D.
And I know there was a comment before about procurement or a potential, I guess it was presented as a myth that, procurement teams didn't want to engage with potential companies in case of giving preferential treatment or being shown as preferential treatment. I've actually seen that happen in a municipal procurement environment. Municipal procurement team actually went after the innovation team for saying, you can't do that. It's breaking laws that we have to follow. And so those things exist. And I think when you're looking at generating use cases, a lot of private corporations don't like airing their dirty laundry. They don't want to tell you, publicly say, this is what I'm really bad at, or here's what I struggle with in that competitive environment.
Something that's like I've never thought about before I was in this industry was just how focused on free market economics the Canadian government is. It seems to be like a driving tenet of a lot of policy decisions. And compared to any other jurisdiction we worked in, it's to an unbelievable extent. And it's actually detrimental to Canadian companies. You mentioned you sold into the French government. I'm amazed by that. Because if you take a look at French quantum companies, the majority of their cap tables are the French government. If you look at Canadian quantum companies, there is maybe a slither of equity held by the Canadian government. And this is a huge difference. Same thing if you look at Japan, you look at South Korea, you look at many jurisdictions around the world, they treat deep tech investment very differently than Canada does.
Awesome. Any final grievances before I give it to the audience? Like what? Well, there's networking later.
Yeah. So I think so like about the procurement. Is this working? Yeah. So about the procurement piece. So I think the issue I think that you were trying to raise about the price support for these kind of pilot first sale contract. I think that it's not really those policies are not really made for world's first innovations, because you're really trying to compare. Has there been any previous sale? If there was a previous sale, then perhaps it's not that innovative, right? So at the end of the day, a lot of the times company end up having to do the price support in terms of what are the resistors that you're getting, these kind of price support that really goes down to the detail of components that cost less than a cent. Sometimes it does go to that level, and we try to avoid that when that happens. So I think there's an issue there in the kind of the pilot deployment demonstration type of procurement contract. But then I think there's this other issue. Once that has been proven, or when the CAF end user likes it, they make that first real contract, procurement contract. That takes a long time. And usually because of the kind of the free trade commitments, if you want to kind of get away with that, maybe you use like the national security exemption or these kinds of clauses that ends up involving many parties, including the Treasury Board, and it just becomes incredibly complicated to actually land that procurement within the government fiscal year. So that ends up being delayed over and over again. So like we had one contract where this actually took 3 years from okay, yes, let's go, to actual legally binding contract from the government. And we're fortunate we have other things going on at the same time. But if that was the only thing that we were relying on, yeah, we wouldn't have survived. And then I think there's this other issue where like we deliver that contract classified, they like it, they want to now build an inventory. The same purchase, but then you want to actually make that the second order, you have to go through that entire process again, another 3 years. So I think that's a issue where it's much easier for IKEA to sell furnitures to defense than innovative products to actually be sold to defense, even when there is a bottom-up strong market pull from the end users. And then I think there's the final piece, which is kind of sitting below the Defense Investment Agency, like the $100 million cap. Okay, let's say that we like these. Let's say that we want to build an inventory and then have give something like a $30 million contract and actually deploy on a ship, see if it works in a over the horizon radar system or whatnot. Yeah, there's no mechanism of doing that. Yeah, so I think that's the issue. If you are trying to pull these SMEs into the next prime, and ITB is not enough, like especially if you're delivering incredibly foundational technology. If you think from the integrator point of view, would an integrator want to be dependent on a small company when a lot of the profits that they get is not just the sale of the the product, like the defense platform, but also the maintenance contract, right? So it just like dynamically, it just doesn't work. Like if it's so foundational that the kind of power dynamics changes, right? So like it's a little bit like Intel and Dell. Which one is more important? Like one is a component company, the other one is a system integrator. It's not very clear, right? So I think they don't want to make that kind of dynamics where they give up the leverage to a small company if it's so foundational, because they can meet the ITB benefit in many different ways. Maybe giving out, like buying Canadian aluminum, like these are very important things. Mass production, giving out, subcontracting the manufacturing piece, of course, it's very important. But in some sense, like if we're really talking about sovereign Canadian technology, it's very important to protect that foundational technology and make sure that Canada has that control. Yeah.
I know that they were talking early this morning. The term speed of relevance was used, and relevance is relative, though, because for a startup, the speed of relevance is actually quite fast, right? If the average age of this is all startups, not just quantum, but like if the average age of a startup to exit, time to exit is 7.5 years or 8 years, with 20 at the far end being like a pharma company, and then a SaaS company being at the low end, right? Quantum somewhere in between. You can imagine different interacting with these different types of startups requires different tactics each time, right? Depending on where you are. So I think there's something about someone had mentioned defense literacy. I think there's something to be said about innovation literacy, about how an organization is able to absorb and receive innovation. Before we hand it off, because there is a room of people in policy, as a startup as startups, you should always have an ask. What is your ask of this room? And I want you to answer, each of you to answer that before we hand it off to the crowd.
Let's switch jobs for a year. I'll go into the public service, and you come work at a startup. But in all seriousness, what I'd love to see from a Canadian bureaucratic policy side is more industry involvement directly in some sort of rotation. Other countries have it since I think the 1970s when we professionalized our bureaucracy. We haven't had that. And there's really, really good things about that. But I think there's also some really detrimental things as well, where we are living in two very, very different worlds. So some cross-pollination between the two would be phenomenal. And more money, but Michael knows that one.
Yeah, my ask would be intentional in what you want to choose to fund, or actually build critical capabilities in Canada. Just pick 2 or 3 and run with it. Like, we will not be able to do everything, and then try to mobilize key actors under that same umbrella to build momentum.
Yeah, so I think maybe fostering the bottom-up market pool that exists, and not taking it for granted is probably
I'm going to echo Rafal's comment about more funding, please. And someone mentioned being intentional about who the funding goes to. I would like to request to be intentional about removing bureaucracy. The paperwork is overwhelming for small companies. Yesterday, I had a meeting with a large grant provider because our financial forecast, detailed one, was 50 cents off from the amount of money we asked for. Too much. That's too much, guys. Okay.
Awesome. Not awesome. Sorry. Any questions? Yes.